Thanks, Ron, as always. Good afternoon, everyone. Welcome. In this part of the session, you'll be seeing like how AWS brings machine learning to SQL users in a way like democratizing the data and machine learning with the help of Amazon Redshift ML, machine learning it stands for. It's a fully managed machine learning service without requiring you to become experts in ML. My name is Ram Konchada. I'm a senior solutions architect at AWS based out of New York City here in the Northeast. And I am co-presenting with my colleague Mamoon Chowdry, who is also a solutions architect. Let me jump right into the agenda. So here's what we are going to talk about for the next 40 minutes or so. We will start with the value of data and the challenges that we face as the data grows, and how modern data warehouse attempts to address those challenges. And we introduce the Amazon Redshift as a modern data warehouse platform and how it helps in building a modern data warehouse, right? So then my co-presenter will start off with the remaining topics covering the power of machine learning, benefits of ML-enabled data warehouse, and how Redshift ML uh, fits into the picture and the challenges that we are trying to solve today. So how are the businesses realizing benefit from a modern data strategy, right? So they're realizing value through data analytics, which is nothing but a process of analyzing data to acquire business insights, which can lead to like enhanced business performance or identify new business opportunities, right? So for example, like what product, what shoe or style that is popular, and streamline operations and even stronger customer relationships, right? So with these kinds of insights with the help of data, wanted to bring up an interesting metric here, right? So by making 10% data more accessible, a typical Fortune 1000 company will see an increase of $65 million in net income. So that's just to put things in perspective, the value of data. So with this explosive growth of data brings in both the opportunities and the challenges, right? We are hear from the customers all the time that they're looking to extract more value from all this growth in the data, right? So think of typical sales, marketing, operational analysts, data scientists, and even the developers. These users, along with the business decision makers, are heavily dependent on easy to use performance systems, and they don't have the skill or the time to be experts in the data management or figuring out like how their analytics tools can scale with the volume of data and the growth in the usage, right? So there's a lot more on top of it, like there's a lot more diversity in the type of data, where the data is coming from, meaning the data sources, right? Most of this data is living in different data stores, different departments within the organization. And without a way to integrate and connect this data that is not fresh and maybe inconsistent, you quickly lose the value of the data. So finally, like how do like customers keep the momentum going with their analysts, data analysts, right? How do they ensure several users use analytic systems concurrently without slowing down or degrading in the performance and not overly dependent on their central IT to tune their systems or prepare their data, right? So at the heart of like managing these issues for diverse users within an organization lies a robust, efficient analytics system, and along with that, a robust data strategy as well. Think of data as a flywheel that enables like the productivity and the business outcomes among the different data users within an organization, right? A company's data strategy should be about empowering all these new types of data users and harnessing the value of different types of data available to these users in a really in a scalable, efficient, and a seamless way, right? Um, can you move on to the next slide, the follow-on slide, Mamoon? Yes, right. So at AWS, we call such an analytics system the modern data architecture, right? Like, what does that mean, really, right? The first is like you need a scalable data lakes where organizations can move like any amount of data from various silos freely in and out. Right. Customers are building their data lakes on Amazon Simple Storage Service, or Amazon S3, we call it, than anywhere else. S3 provides industry leading storage scalability, data availability, security, and performance. It is built from the ground up to deliver like 11 nines of durability and stores like millions of applications, data for like millions of applications for companies around the world. And the second, in addition to using a data lake, organizations also use purpose-built data stores for both databases and analytics to get the best performance and cost advantage for their use cases, with using services like Amazon Aurora for processing transactions at high speed, or maybe using Amazon Open Search service for storing and analyzing large volumes of log data at low cost, right? And the third tenet of modern data architecture is like, as more and more organizations store their data in S3 data lakes and also in purpose-built data stores, they often need to access data across their data lake, data warehouses, and the purpose-built data stores in a secure and a compliant way. So to do this, organizations can use AWS Glue to effortlessly move and keep data in sync between the all the data stores, like the data lakes, data warehouse, and the purpose-built data stores, purpose-built stores using Glue Elastic views. Finally, machine learning is one of the most disruptive technologies of our generation, right? It can help create entirely new revenue opportunities, make better, faster decisions, or improve operational efficiencies, right? It needs to be bought for machine learning to be used more widely, right? That machine learning capabilities needs to be brought closer to the data, closer to the data lakes and purpose-built data stores where much of the data needed for ML resides, right? So to bring in ML closer to the data, AWS provides like built-in integration of ML with its purpose-built data stores and other BI services. So now the question is like, how do you get to this more modern data architecture, right? That's where Amazon Redshift comes in. The beauty of the Amazon Redshift is in the scale of data it operates on, unifying data silos with consistently like high performance while keeping your costs predictable. That's the key, right? So we've been laser focused on delivering performance at any scale for our customers. Redshift today offers like 3 times better price performance compared to the other cloud data warehouses, and we will continue to innovate here. Red, excuse me. And Redshift is the only cloud data warehouse that lets you run queries at exabyte scale against your data lake, along with your petabytes in your cluster, while also enabling like querying of operational data stores such as Amazon Aurora. And as data gets more democratized in its usage within your organizations, Redshift is delivering on easy analytics for like everyone, whether it's in a way you query the data or the way you get started or the way you scale. So customers use Redshift for like, can you scroll to the next one? please. The next. The next slide. Yeah, customers use Redshift for variety of analytics use cases, such as modernizing their data warehouses, gaining insight with their BI tools, predictive analytics, and real-time streaming analytics as well, right? So there are variety of user personas use Redshift, like importantly, like the data warehouse users, right? They have different expectations from analytics platform like such as Amazon Redshift. We hear from them that they want to use machine learning with their data in their data warehouse. Next slide, please. So what we hear from customers all the time is that, like I said, they're looking to extract like more value from the data, but like struggle to capture, store, analyze all the data that is generated like through their businesses, right? Data is growing exponentially, coming from new sources, but at the same time, it needs to be securely accessed by any number of applications and people, and is increasingly diverse, right? We also know that costs can escalate quickly and without delivering the value you need, right? It can be difficult to know what to expect and to keep up with the growth of data, users, and the use cases. Next slide, please. Given all these challenges, right, like why have customers decided to choose Amazon Redshift? First is like our lakehouse architecture. Redshift Spectrum has enabled customers like you to query the S3 data from where it lives. As more customers want to query all their data, we have expanded the capabilities to query relational databases to combine with your operational data. And the second is like Redshift provides like fast performance at any scale, whether you're just starting or an advanced user. It provides like performance and scales to your needs. Like with RA3 nodes, we have enabled best-in-class performance. Like with the RA3 nodes now, the customers can scale, compute, and storage independently, right? And in addition to that, like Aqua is built on RA3 nodes, and it provides a new hardware accelerated cache, and it will boost certain queries up to like 10 times faster compared to the other cloud data warehouses. Finally, and most importantly, we make your costs predictable even as your workload scales. Next slide, please. I want to quickly run through like how a modern data strategy would look like in action, right? A modern data strategy is enabled like by a set of technology building blocks that help you manage, access, and act on the data, right? It gives you like multiple options to connect to data sources, right? Along with that, like it should empower your teams to run analytics or machine learning using their preferred tools and techniques. It should let you break down the data silos and should give you the best of both data lakes and the purpose-built data stores. And it should enable you to store any amount of data at as lower cost as possible and in open standardized based data formats, right? And AWS offers the most comprehensive set of tools for the end-to-end data journey. I'll end with a quick example, like next slide, please. Yeah, I wanted to give you a quick example, like how Pinterest gained value with AWS. Like as one of the largest visual discovery engines in the world with over 400 million monthly active users, Pinterest, like this sort of solution to address the growing volume of data it needed to ingest for its engineers to effectively analyze their log data, right? They moved to manage analytics using Amazon Open Search Service, enabling it not only to scale its log analysis capabilities, but also reduce the burdens of operations, and they improve the security along with saving the costs. And lastly, like, they were able to scale their daily log search and analytics from like literally 500 gigabytes to 1.7 terabytes, and they reduced their operational costs by 30%, and soon to expect that to be like 50% or so. And they increased their productivity by like freeing up software engineers away, keeping them away from undifferentiated heavy lifting, right? And and for like its inclusion, diversity, and equity efforts, Pinterest uses like S3 access points to help amplify their underrepresented voices as well. And that ends my part of the presentation. And now my co-presenter, Mamoon, will walk you through the benefits of ML and how AWS enables the users with machine learning through Redshift ML. Mamoon?
Ram and Mamoon, just one question again from Jim with the State of North Carolina Department of Justice. Can you at least describe some of the low or no code services or solutions offered by AWS?
Yeah. So the low code, no code, meaning there are different ways of addressing the low code, no code, right? Like just like the way other gentlemen expressed, like how it is achieved, right? That we have like ready-made connectors available. We have like few drag and drop features that generates the code for you, right? So what exactly like are they looking for? I'd love to learn more about it and be specific to their questions.
Yeah. So good afternoon. This is Mamoon speaking. Just to add on to my colleague Ram's comments, we have a variety of low-code services because one of the things that we've been trying to do as a company for many years is enable people to build cool things, whether it's cool applications or cool solutions, regardless of the skill set that they bring. So increasingly, we have customers who are not just asking developers to build things, but also business analysts and middle managers and so forth. And so we do have a number of low-code solutions. For example, we have SageMaker Canvas, which is a low-code solution that allows you to build machine learning models without having to write a single line of code. We have Amazon Honeycode, which allows you to build web and mobile apps using a drag and drop interface, again, without having to write a single line of code. And then we have services like Code Guru, which are not necessarily not necessarily low-code services, but machine learning companion services that allow developers to define what it is they're trying to build, and the machine learning model writes the code for you. And so we do have a variety of services there, and we'll continue to add to those based on customer feedback.
Mamoon, I just sent you Jim's email address in the chat, so you can follow up with him separately, or have one of your colleagues down there in North Carolina, since you're based in the Northeast, follow up, who handles government accounts in the Carolinas.
Indeed. Yeah, I'll be happy to do so. Thank you so much. Okay, so I would, as Ram mentioned, my name is Mamoon Chowdry. I'm also a solution architect at AWS. Please forgive me for not being on video. Apparently my video camera has decided to malfunction, but hopefully you can still hear me okay. Please stop me if you cannot. All right. In the remainder of the presentation, I'd like to talk a little bit more about the machine learning capabilities that you can use on top of a data warehouse like Amazon Redshift. The very first thing that I would say, for those of you who are not machine learning practitioners, if you don't use machine learning on a day-to-day basis, it can produce really, really valuable insights, but it is difficult to do. Machine learning has come a long way in the last 10 to 15 years, especially. It used to be that there were a certain category of tasks that you could only ever give to a human being or a domain expert. For example, translating from one language to another, or forecasting potential sales, or doing things like identifying fraudulent transactions. Very often you needed human beings who are domain experts to sit down and look at spreadsheets of data to kind of make some decisions. And that was very often a long, kind of drawn out manual process. What we're finding now is we can teach machines to do tasks that up until very recently could only ever be done by human beings. Think of, if I upload a picture to Facebook, for example, it automatically tags me. It knows who are the people in my family, and it tags them, for example. It's a machine that's doing that. And so machines have very, very powerful capabilities, but we're not yet at the point where it's easy for everybody to build machine learning into their day-to-day work. So let's talk about that. First of all, here are some of the things we see customers using machine learning for, and Redshift-based machine learning is no exception at all. We see customers using machine learning to predict when are their customers getting dissatisfied, when are they likely to be delighted, how likely are they to respond to a marketing promotion, for example. So now, rather than having maybe a human being or a call center agent or a concierge having that intimate relationship with each one of your customers, you can have a machine learning model kind of try and predict what is the state of your customer and begin to have a really intimate, kind of close relationship with that customer, even though you may have 1 million customers or many more customers than that. And so understanding your customers in greater detail is a great use case for machine learning. Also forecasting things. We see machine learning commonly used in supply chain, for example. How many widgets should I keep in my warehouse in Boston, Massachusetts, for example, for the next 30 days? How much of a particular thing am I likely to sell? Is the price of something likely to go up or down? Is there a particular product that I should kind of offer to my customers, part of a promotion or a next best purchase, for example? Can I identify fraudulent transactions and fraudulent behavior? Can I predict when a customer signs up and I've got no history about them, but from the information that they've shared with me, can I predict what is the possible lifetime value of this customer? Are they likely to be big spenders? Are they likely to be infrequent spenders? And so forth. And so these are the questions we increasingly find people asking with the data that they have in an enterprise data warehouse. Now, some of these you can begin to answer using, some standard SQL queries and some reporting, but these require really intelligent insights and a really kind of clear understanding of historical data to make high quality decisions and high quality recommendations. And that's where we find machine learning is being used. So being able to use machine learning on top of a enterprise data warehouse is really, really key, especially for those organizations that really wish to differentiate themselves. Now, if you're not familiar with how machine learning typically works, it's not too different from how you may train a human being. Let's say, for example, you're training a human being to drive a car or ride a motorbike. You may start out with some examples of what is good driving decisions and what are bad driving decisions. For example, what should you do when you see a stop sign? What should you do when you see a red traffic light or a stoplight, or a pedestrian trying to cross the road? All of these are kind of examples that we may use to teach a human being in a particular task. And the same applies when we're teaching machines to do intelligent tasks too. But rather than communicating examples through an instruction manual, or a mentor or a human trainer of some sort, we'll actually create examples in the form of data that we feed into a machine learning model. And that's how machines learn. That's how they learn to make things like price predictions, classifications, image analysis, language understanding, speech to text. All of those things are built by training a machine on what a good examples and bad examples of, language translation, for example. So we do a lot of training in much the same way that we may train a human being, although we do it at much larger scale. Now, when you train a machine learning model, you may have a model that can make fairly accurate predictions, but now you have to deploy it. You have to actually make it usable. Maybe you make it usable through an API, or you put it in a batch script somewhere. And so forth. And very often, I don't know about you, but I'm not the same person I was last week or the week before that. Human beings change all the time, and our world changes all the time, which means that the decisions your customers are making is also going to change as well, even if all other things stay the same. And so we constantly have to update our machine learning models. So we may go back and say, okay, now let's look at the last 30 days of sales data and refresh our model so that it's more up to date. And if we don't do that, we'll find out our models will get less accurate over time. So there's actually a lot of steps to using machine learning traditionally, and they're very iterative as well. It's not common that you would go from the left-hand side of this chart to the right-hand side in one fell swoop and come up with a machine learning model. Very often you may train a model and realize, yeah, it's not really working well for a particular market or a particular demographic. So I have to go back to the drawing board and retrain a new model, or whatever the case may be. So there's lots of iteration, there's lots of complexity. And even then you may think, well, that's not a big deal if we've only got one machine learning model. But a lot of our customers may have 1,000 machine learning models, or 20,000 or 100,000 machine learning models. And now the complexity of managing machine learning at scale becomes an exponentially more difficult problem. And so machine learning, even now, can be really tough. But that doesn't mean that people don't want to use machine learning on top of their data in their data warehouses. We see data analysts all the time that want to be able to make intelligent predictions based on machine learning techniques, but don't have the skills or the resources to learn and become machine learning domain experts. We have data scientists who may well be, well versed in machine learning, but don't. But want to be able to do that very easily on the data that's already in a data warehouse, rather than trying to export it out and do their own ETL and so forth. And then we have people who are, commonly tasked with providing insights back to their business counterparts, and so they want to be able to use machine learning predictions in their forecasting and in their reporting as well. But again, they don't want to have to be able to. They don't want to have to become machine learning domain experts, or they don't want to get bogged down in the operational complexities of managing thousands of machine learning models. They just want to be able to very quickly build a model and then use a model. And that comes back to the mission that we have at AWS, is we want to make sure that anybody has the opportunity to benefit from machine learning in their line of work. Those who are technical, those who are non-technical, those who are business users. And it shouldn't matter where your data is. And for many enterprises and organizations, it is in an enterprise data warehouse. So you should be able to apply machine learning to that data, hopefully in place, with a minimum of trouble or effort or training required. And so that's the mission that we've taken on for ourselves. And that's one of the ways in which we serve our customers. So now, let me talk a little bit about how Redshift machine learning works. Well, my colleague Ram talked about some of the benefits of Redshift as an enterprise data warehouse, which you see on the left-hand side of this slide. So there's a lot going on here, but essentially Redshift is a very flexible, scalable, cloud-native data warehouse that can allow you to query your data, in an OLAP model, regardless of where that data is or what format that data might be in. What Redshift also gives you is the ability to apply machine learning on top of that data. So whether it's in S3, whether it's in a federated database, whether it's locally held in Redshift, you should be able to apply machine learning to it. And essentially the process is very simple. Once you have data within your Redshift data warehouse, you can create a model using a SQL syntax. You can train a model, so you can select the examples in your data warehouse for that model to learn from. And then you can begin to deploy and consume that model as well by invoking it, again, for a SQL query to get predictions from that model. And I'll show you how that works. But what our customers tell us is it's really, really valuable to be able to apply machine learning using that existing SQL construct, using that language that they're familiar with, and it's incredibly powerful for them to make their analytics much more intelligent by actually having an easy way to train the machines on your data and make predictions about new data that you may see. And at a very high level, it looks something like this. At the top of this chart, you'll see a SQL query that creates a model, a machine learning model. And it's fairly self-evident. It's like doing a regular select query from a table, except that you are selecting data for a machine to learn from. In this case, we have a table called customer churn, where we're selecting some columns, and we're using that to train a model. Now, when we're training a model, we have to ask it to try and be able to predict something. Maybe it's how much that customer is going to spend next month. Maybe it's the likelihood that the customer is going to churn or be dissatisfied, or the likelihood of that customer responding to a particular marketing campaign. But whatever it is you want the machine to try and predict, that's what we refer to as our target. So when you create the model, you don't just select the data that you want to train that model with, but you have to tell it what it is to predict. Is it sales for the next 30 days? Is it like future customer satisfaction, whatever the case may be? At the bottom of the half of the chart, you'll see what an enterprise data warehouse user may do when they want to use that model to get some intelligent prediction. And again, it's a very, very simple SQL query. They're selecting data from a table, they're invoking a function as part of that select, and they're running for a particular part of their data set. And it's as simple as that. It used to be that you had to write thousands and thousands of lines of code and have an army of data scientists to do this. But here, in two very simple SQL queries, you could train a machine on your own data, and then you can have that machine give you intelligent predictions on that data. So you don't need an army of data scientists, and you don't need to write tens of thousands of lines of code. It really is as simple as these two SQL queries right here. So one of our customers at AWS is a company called JobCase. JobCase is a job search website. They have about 20 million users every day. And you would go to this website if you were looking for a new employment opportunity. You may search job listings by role. For example, you can execute all different kinds of queries. And one of the things JobCase does is it tries to look for job postings that are similar. So let's say, for example, you are a data scientist and you're looking for data scientist related jobs. Well, JobCase will use a machine learning model to predict the similarity between different job descriptions. And so that machine learning model may understand that a research scientist or data analyst has some similarity to a data scientist. So somebody searches for data scientist jobs, it may surface some of the other categories as well. Similarly, if you were a registered nurse, it may also show you jobs where you are a staff nurse or a school nurse or a case manager or whatever the case may be. And that's driven through a machine learning model running on their Redshift database, which essentially predicts the similarity between two strings that represent job titles. So they do this at a huge scale. They run 2 to 3 billion predictions within the span of about 15 minutes. They use that same SQL interface to build their machine learning models and deploy their machine learning models on Redshift. That analysis that they do, it used to take them weeks, and now it takes them days. And it's significantly cost effective. People, often wonder, well, this is great, but is it going to double my enterprise data warehouse costs? Well, no, it doesn't. And I'll talk about that in more detail. But we don't charge for actually making predictions using Amazon machine learning. And so that's something that is, just part of the service. The result was for JobCase that they found that there was between a 5 to 10% increase in member engagement, and that is really significant. 2 to 3% is usually pretty good, but 5 to 10% is huge. And across the millions of users that they have, that's a huge uplift opportunity for them as well, all driven through machine learning. So to summarize, customers are using Redshift machine learning because it's real simple. They can use the language they already know and love, which is SQL, to build, train, and use machine learning models. It's actually really flexible as well. You can just have Redshift kind of figure out what kind of model to use based on the target that you specify, or you can have many different types of models that it can use to train on your data. A lot of the intricacies around operationalizing and training models at scale have been automated away in Redshift ML, so you don't have to worry about a lot of the things that people typically have to worry about when they're doing ML ops, as we call it. And also because everything is happening within a locally cloud native, elastic, scalable data warehouse, it's very performant as well. So you could train your model across, billions of rows, petabytes of data, even exabytes of data if you wanted to make sure that you have really powerful machine learning models giving you predictions. It comes with all of the same security that you get with AWS services and Redshift as well. And I mentioned that there's no incremental costs for actually generating predictions using Redshift ML. So let's talk about what this may look like for a real world use case. Let's say, for example, in your organization, you are involved with selling a particular product or a widget or a service. In this example, these are sporting event tickets. Now, typically a data analyst may be approached with a business problem. For example, hey, our sales are going down and we don't know why. Well, a business analyst may kind of log into the data warehouse and run a simple query like this to see how the sales are doing from month to month. And indeed, you can see in months 11 and 12 here that sales are declining dramatically. Now, if you were just using traditional data warehouse techniques and SQL queries, maybe there's a little bit more analysis you could do, but it's all historical and backward looking generally. And so most people would actually kind of stop there in terms of their analysis. You could certainly dig a little deeper to understand where specifically in the country those sales may be declining. But with machine learning, you can actually go a number of steps further. For example, we may have a hunch that there are certain factors that influence the ticket sales, and we may wish to have a machine investigate those and see if we can make some high quality predictions to prevent future slumps in sales. And so, for example, you may look through the table and say, look, these are all really interesting things. I suspect maybe who my team is playing will affect the ticket prices. I suspect the section may be important, or the seat number may be important. The face value may be important as well. So all of these things I'm going to select and feed into a machine learning model. And so that's the next thing that you would do in Redshift ML is you would select some of that data and you would use it to train a model. In reality, you wouldn't train a model on 100% of your data because just like human beings, machines can also memorize things. And so when you're training any kind of machine learning model, you typically want to keep some data out. You want to just set it aside, and that data we use for testing and validation. And really, we want to make sure that nothing was unwittingly memorized. Otherwise, what will happen is you may have, a terabyte of data and use that whole terabyte to train your machine learning model. And eventually it becomes 100% accurate because it memorized every record in that training data. And then when you put it in production, it performs terribly. And the reason is it's learned to memorize your training data instead of actually learning to make intelligent predictions. So when we're training a model, we always keep some data set aside to test it. So we always test the model with data that it has never seen before. And that way we can be sure it's going to work pretty well in production. And so here again is how you would train a machine learning model. It's a very simple select query, essentially. So we're selecting our input data. We're defining a target. So the thing that we want to predict is the final resale ticket price. And we can tell it what kind of thing we want to optimize for. we're going to use an objective called mean square error. And really all you need to know about that, if you're not familiar with that term, it's simply a mathematical function to indicate the error or how far off our prediction is. Is it off by 50%? Is it off by 5%? Is it off by 100%? At a very high level, that's what MSE is. And that's essentially it. So once you execute the SQL query, Redshift will go select the data, feed it into a machine learning model, train that model. And if you ask it to explain, just like you can explain plan a query, you can also explain a model in Redshift as well. And here's the results. So here's the model that was trained. Now, one of the really important things here is it will tell you, one, that what is the state of that model? Is it training? Is it ready to be used? How accurate is that model? So that's the validation mean square error that you see. So here it had a mean square error of 0.2, which is, I think, is pretty good here. And the other thing that's really important is also tell you the query that was used to create this model. And that's important because a lot of our customers exist in highly regulated industries. And so if you use machine learning, very often you have compliance people and auditors who will want you to explain, hey, why did you price this a particular way for this person and this for another person? How can you prove that you didn't discriminate against somebody based on their language or their identity or whatever the case may be? But here, what I've got is an audit trail. I know exactly what this model was trained on. I know it wasn't trained on any, I can see it wasn't trained on any information that was confidential or private. There is no field in here that represents gender or religion or whatever the case may be. So I can now show this to an auditor and say, look, here is the proof that I am compliant and I'm not unwittingly discriminating against anybody either. Now, once we've got a machine learning model, we can actually go and validate it. So we can say, okay, show us the actual prices that we've got historical data for, and then show us what you could have predicted if we'd had asked your opinion in the past. And here we can see that the actual prediction are pretty good. The percentage difference is very, very small within, a few hundredths or a few thousandths of a percent. So it's actually really good at predicting prices in this example. And so now conceivably what we can do is we can go back to our business counterparts and say, well, if you give me the details of a sporting fixture that you're setting up, for the season, I can tell you roughly how much I think we're going to sell. Now that is an order of magnitude way more valuable to people than a historical kind of backward looking report. Because now I've got something that I can actually make business decisions about. I can actually maybe fine tune how I'm selling tickets to increase my revenue. And in fact, I can even go even further. I not only can I predict, a game that the ticket prices of a game that's yet to happen, but I can also ask the machine learning model to tell me what has it learned. And let me just kind of repeat that again, because this is a point that people often don't realize is a lot of the value of machine learning is that once a machine has developed, the equivalent of some human instinct, you can actually begin to ask it, well, why did you predict that? What were the factors that led you to predict this customer is going to be dissatisfied, or that they're going to make a big ticket purchase, or that the price is going to be, $122? Why did you do that? And here, just as we can explain plan a query, you can also explain the model as well. And that's exactly what you see here. What it's doing is it's showing for all of the inputs that we gave that model, what is the correlation between the output? So again, in this model, we're trying to predict the final ticket price. And in the data that's being returned from our explanation of the model, we can see that the city is not that highly correlated, is not that relevant. The event date is a little bit more relevant. The actual face value of the ticket, the list ticket price, is very relevant. And actually the seating section as well. The seating section is way more relevant than the actual row or the seat level, indeed. So now I can go back to my business counterparts and I can say, hey, we think that our ticket prices, our ticket sales are highly correlated to the individual section and who the away team is for that particular fixture. Now I know that. I can maybe design a marketing campaign. Maybe I can offer, some kind of upgrade or some kind of discount to fill in the least popular seating sections or whatever the case may be. But here now, I've got a number of avenues that I can explore with a business counterpart to actually influence revenue moving forward. And that's really some of the incredible value that people get out of Redshift machine learning. Is I'm not just doing historical backward-looking queries, I'm doing forward-looking analytics where I'm giving real feedback to the business based on what a machine has intelligently learned about the performance of that business. So, at a high level, that is what how a user may use machine learning to tackle a business problem. But there's actually lots of different business problems that you can tackle with machine learning. I mentioned churn prediction before. So this is really understanding what is the likely satisfaction of a customer with your product or service. Can I predict as a business how well my sales are going to do in the future? Can I classify something as being fraudulent or not fraudulent? Can I predict the lifetime value of a customer? Can I detect if a customer is going to stop using my service or default on the service, and so forth? From the machine learning aspect, some of these are what we call regression problems. A regression problem is really where you're trying to pick a number. Hey, how many millions of dollars of sales am I gonna get next month? That's a regression problem. Sometimes it's a classification problem. Is this picture of a mole that somebody took with their smartphone, is that likely to be cancerous or not? That's a simple classification problem. Is this transaction likely to be fraudulent or not? That's a binary classification problem. And then we have multi-class classification as well. Multi-class classification is a huge opportunity for businesses across different industries. If any of you have watched a movie online, you may see a widget that says customers who watch this movie also like this movie as well. That kind of grouping of customers, or grouping of products, or grouping of jobs, as you saw in the job case example, is an example of multi-class classification. And that really helps across industries connect potential customers to potential products and services very easily by understanding how customers are similar to each other, what those demographics look like, and how your products or services are also similar to each other as well. Really, really compelling. Across industries, we see this as a very common way in which customers kind of improve their customer experience. Diving a little bit deeper, there's a lot of machine learning algorithms that you can use. If you're not a machine learning expert, that's fine. The only thing that I'll ask you to take away from this is we're constantly adding new types of machine learning techniques to our machine learning services, and that means that you don't have to be a machine learning expert. You have the latest and greatest machine learning capabilities available to you in the Redshift platform without you having to download anything, learn a new model or a new technique. It's all going to be available in that same SQL query that looks something like this. Now, you've seen an example of this before. Again, to create a model, really, really simple. All you need to know is a select query and what it is you want that machine to learn how to predict, and that's what the target is. Very, very simple. Can't make it more simple than that. When there's also a full audit trail as well, which is very important, especially in highly regulated industries as well. So if an auditor ever tells you, show me how you trained this model and show me why it behaved the way that it did and show me what it was trained on, these are all questions that are normally very, very difficult to answer, but that audit trail is automatically made for you within Redshift. And again, generating predictions from Redshift is very, very easy. It's just another select query where you invoke a function. You can use workload management as well. If you're doing large batch predictions, you can use workload management to make sure that you're not impacting the performance for other users of that data warehouse as well. And just like all of the other Redshift operations, they can be incredibly highly parallelized as well, which means it shouldn't matter if you have terabytes of data, petabytes of data, or exabytes of data. You can run machine learning in a highly parallel manner with Redshift. There are many different problem types that you can address as well, between regression, binary, and multi-class classification as well. The vast majority of use cases kind of fit within these categories as well. And finally, machine learning, one of the barriers to adoption we find is that sometimes it can be expensive. It involves a lot of number crunching to actually learn from data. And so what you can actually do is, in Redshift, you can say, learn on the first 100,000 records, or the first 1 million records, or whatever the case may be, or spend no more than 1 hour learning my data. And so you can put very clear guardrails around it so that you can control the cost of training your model. The actual use of the model is not something we charge for. That's free. So you can make as many predictions as you like. It's included with the service. I talked about the job case example already. They perform billions and billions of predictions, machine learning predictions in their data warehouse. And it has an immediate effect on their business because they see between 5 to 10% improvement in revenue and engagement just by using machine learning to guide how they present their service or product to their customers. Magellan Rx is another customer of Redshift machine learning, and they're particularly involved in drug discovery. So they look at databases of different compounds. So you may have a database of 100 million compounds, and trying to understand or predict which compound could be used to treat which particular condition. And so it's really a highly, a very big multi-class kind of classification problem. And they're able to bring new drugs to market because they're using Redshift machine learning to crunch through a huge database of compounds and a huge database of potential conditions, and understand, if you can go through 100 million compounds and produce 10 candidates that you can send to a lab to test, that's really, really compelling and valuable. So that's another way in which Redshift machine learning has been valuable for our customers. So with that being said, I've come to the end of our presentation. Talking and sharing with customers like yourselves is probably the most favorite part of my job. So thank you for the opportunity. Thank you, Ron, for arranging this. We've taken the liberty of including our email addresses here because we love to hear from customers like yourself. So if you have any questions, thoughts, comments, feedback, please don't hesitate to reach out and shoot us a note. With that being said, Ron, may I hand over back to you?
Yeah, that was great. I know that Jim from the state of North Carolina, and I've sent you details, had questions on how do you benchmark AWS versus other companies. He also had questions, do you have templates? Maybe you can comment on that. I'm assuming that your approach is somewhat similar to what Sri from Microsoft had mentioned earlier, that there are some existing API solutions already pre-built. So if you're a citizen developer, you can still take full advantage of the AWS engine. And at the same time, for more customized applications for the PhD data scientists out there, you've got the ability to dig deeper as opposed to working a higher level. Is that about right, Mamoon?
It absolutely is. So there's a couple of things that I'll say. One, Redshift is one of our fastest growing services, and it grows incredibly fast because we iterate very quickly based on customer feedback. And so, to the first question, we don't really pay a lot of attention to what other companies are doing with their products. The only reason, or I think the main reason we've been so successful is we listen to customers and we build based on what customers tell us they want. We build based on what customers tell us they need, and we build based on what they tell us they don't like as well. And so we really thrive on customer feedback. We don't really worry about what other people in industry are selling. That's not that important to us. But what is important is what our customers want, and that's what we build. And 95% of our roadmap is based purely on customer feedback. Secondly,
finish up, Mamoon.
Yeah, and secondly, I would say, a lot of customers, when they dabble, or they begin to approach something like machine learning, they look for examples, pre-built examples, APIs, things that they can try to learn from. And we do have, very broadly documented examples, both for Redshift ML and for SageMaker. Like if you are that PhD data scientist that wants to build your own model from scratch, we have services for that as well. If you are a business owner who has never built a machine learning model in your life, or maybe you've never written a SQL query in your life, we have no code machine learning capabilities as well. So what you'll find at AWS is we really have the broadest platform for the broadest range of personas. So whether you're a citizen developer or a data scientist or a non-technical executive, you'll find that there are services for you, especially in the area of machine learning, so that you can bring it into your day-to-day work at the level and in the way that really kind of makes sense for your own personal goals. We don't believe in one size fitting all. We don't believe that there is a magic, tool for everybody. And so that's why we have the broadest portfolio of cloud-based services that are available out there. Simply the breadth and depth of the platform is unmatched. I hope that goes to that helps to address the question.